Alrighty, hopefully you had a good break and actually got some time off to just chill. So we're coming back. We've got streams today, ethics on Wednesday, and then our last lab assignment. Next week, I don't have any plans for new material. So the plan was to just show up and answer questions about the group project for you folks to work together. And then does anyone want to meet with Mr. Dia next Wednesday? Or should I just tell him no lab? Okay. Yeah, I think that's fine. So take that lab time that you would be here to work with your partner or on your project if you're working individually. We could work there. I don't know how many questions he'll answer, given it's the final project assignment. Is that fair? Like, I don't know how much he'll actually be able to help. Like syntax errors and things, yeah, for sure. Definitely he can help out with that. But other questions, I don't know. Is that we can try it and see. Say hey, anyone wants to come, go for it. I wouldn't expect a lot of answers. Is that like guidance? Is that more fair to say? You know, like pointers. Mhm. Okay, yeah, for help with the small things, for sure. Mhm. Okay, yeah, definitely. So no assignment, and we'll just come and have some work time. Makes sense. So that's the plan. So streams, you didn't do any file input and output in 150, right? You did? Okay. All right, cool. So not too much new stuff then. Some review here. The rest of the stuff in the chapter about like formatting and stuff, I'm just going to skip over. Is that okay with you? Did you do input strings before? You can use a string and then you can like cin off of an individual line, or using get line instead of cin to get into. Okay, cool. So we'll focus mostly on the input and output because this is very interesting conceptually with how do we take data and store it somewhere. Because everything we've done so far has been looking at how do we use data in memory, right? When we shift to files, there's a whole different way of storing this data, right? It needs to be in a format that we can read and write. And really those go hand in hand. You can't read the data unless you know how it was written, or if you know how you want to read it, you will write it in a certain manner. So you pick what your reading format is or what your writing format is, and they're basically the same thing. And it determines how you read and write your data. So if we wanted to take our information and write it to a file, we need to know how we want to lay it out, so we can go and read the file later. And the focus here is just text-based files. We don't even get into binary files at all. Like if you go and open up just like a Word document here, some text document here, it's a bunch of text, right? You can just type in some characters. Nothing very interesting here. But it's there, but you read it as text. So I can put numbers in here, right? 1, 2, 3, decimal notation sort of thing, but it's all characters that's being stored. That's those Unicode values. Where if I were to make like a Microsoft Word document here and put something in here, numbers, whatever here, save and close it, I can open it with a word editor in Notepad, text editor, but it's going to be garbage because it's not meant to be read as text data. So the difference here, where this is a text file, this is a binary file. The data is stored in a binary format that a particular application knows how to go and read. So the Microsoft Word application knows how to go and read Microsoft Word documents. It knows how to open it up and read the data back out, where just opening it in our Notepad is nothing. Some of it actually is words here or text here because there is some text content, but most of it doesn't render as text because it's not text. Right? Whatever information is stored here is just a bunch of zeros and ones. We have to know how we're going to store it here. So when we're reading and writing files, if we're just doing text here, right, everything has to get converted to strings, written out as strings. When we read it in, we're taking the text and converting it back to whatever our data is. It's pretty easy with C++. We can just input it, essentially use that extraction operator, just like a cin. It will convert for us if we know the format. But if we don't know the format, bad things will happen. So we got a couple options. So I started the new project here, called it streams. And let's see if we can't read and write some data here. All right, so we're going to include our IO stream, and then we're going to include, we want O stream for output streams, include F stream for file streams. That's all we need. Name and user namespace. I thought there was an additional thing we needed in here. We'll see if it works without it or with it here. So we definitely need the file streams. I thought we needed this for something. I'm trying to remember what it is now. But let's go and write a file first, and then we'll go and read the file. So we'll go make a file here, and then we'll go see if we can read the file afterwards. So it might actually be fun if we ask the user, like, what's the name of the file that we should write? We can kind of do this dynamically as we go. So if we want, we can have our string for the file name, and then we can get the file name from the user. Right? We'll go ask them, hey, what's the name of the file we want to create? So we can kind of do this dynamically. So we'll ask them the name of the file to create, and then we can see in our file name. File. I can't see my, even at this large of a font, it's really hard to see without my glasses. I'm sorry. This will be fun today. And then we want to go and open the file. I'm just going to steal this here because this is easier. So our OF stream, and then we call open on our OF stream. I don't like outfs. I think that's a terrible name. File output. Is that better? Thank you. And we'll just use the file name here. Now, sometimes people will tell us, hey, I want test.txt, and they'll add in the .txt for us. That's handy. Now, you don't actually need those file extensions, though. You can make a file without a file extension. So if I just have test. Now, Windows warns me. I don't know, Macs probably do. I'm not very familiar with them, unfortunately. It says, hey, it might become unusable. It's not unusable. That's actually false. But when I double click it, Windows has no idea what to do with it because there's no file extension. The only reason we have file extensions is for your operating system to know what program you like to open these files with. Right? If it ends with .docx, Windows knows, hey, I should open it with Word if I double click it. If it ends with .txt, Windows knows I should use Notepad. If it ends with .sln, I should use Visual Studio. It's just a shortcut for your computer to know what kind of program it should use to open it. But I can still open it with any program that I want. I can use my open with option here. I'll just open with Notepad. It's still a text file here. I can still put a bunch of text in it. Windows doesn't care. It just isn't as easily used. So it doesn't really matter if the user gives me an extension or not. It's not all that important. We could check for it. We could add it in if we wanted to. We got all sorts of string operations we could look for and see if it contains sorts of the value.txt or has a dot in it somewhere or anything like that. But it's not too big of a deal if we're doing that or not. Then want to make sure that it is open here, right? Make sure we actually opened our file here. If it's not is open, bad things happened, right? We can output an error message and crash or whatever we want to do here. Unable to open file. Please try again. Or something. We don't really have a try again. There's no loop here, but sure. We could do something. And now let's go and write some stuff. So we'll take our file output. Oh man. And what should we write to it here? Right. Happy Thanksgiving. 45 and 23. Those are interesting numbers. 25 to 23. Sports ball. Yeah, okay, sure. Why not? Let's give it a run, see what happens. I forgot to close it. We should close it after. File output, close. It'll get closed when we're done, but so sportsball.txt, right? And it stopped. Should remember to close it. File output, file out. Come on. File output dot close. Still, it's hard to see. I'm sorry. It's blurry with my glasses on though too. All right. Now, maybe a file out there. All right. Well, where did it go? So let's take a look at our solution here. When we use file names, where everything is going to be relative, so it'll be relative to where the program's running, unless we give it a full path. You can give it that fully or an absolute path, like, hey, C drive, colon, my users folder, colon, Eric C, colon, documents, or not colons, backslashes. Sorry. Like C colon's the drive, go on my C drive, and then from there I could put it in other spaces if I want, right? So here's my C drive. This is this path here. Put it in users, put it in Eric, put it in documents, put it in GitHub, put it in my CIS 200 folder, right? In streams, here's sportsball.txt. So if I don't give it the absolute path, if I don't say specifically this location starting at a drive, it'll make it relative to where the program's running. So when we ran our program in debug mode, it runs in this location. So I have my sportsball.txt file, and it says Happy Thanksgiving 45 to 23. So we were able to write the file. Yeah.
So if you want to do this with multiple files, you have to close and open if you want to type into your files or do file output.
Yeah. Or you could use multiple streams, right? So I only have a single stream, so I could close this stream and then call open with a different file using the same stream.
You have multiple streams open at once?
Yeah. Yeah, just be another stream. So we can have web stream, another file output. Sorry, I'm having a hard time reading right now. The dilated eye exam got to me a little bit. Plus txt. How about 2.txt, just in case. We'll concatenate those together, throw them in here, see if we can't have another file output. Make sure we're using the right one here. Another file output here. And then probably make sure it's open, but that's okay for now. We'll take that and say, here's another file. And then we can close that when we're done. So anytime we're working with files, whether it's reading or writing, we still do three things. We open it, we read or write it, and we close it. Now, we can be a little lazy sometimes, and when the program stops, it'll close. But if we have a long-running program, you don't want to leave that file open. It can just be a little silly. So what do we want to call? We'll just call this one test. So we should get test.txt and test2.txt. Right? Test. There's no file extension. We just called it test. And then we added the 2.txt to the other one here. And we got our other file. So you can have multiple streams open if you want. However you want to store that data here. Now, these ones aren't going to be very interesting to read, though, because it's just some text. If we wanted to have some information in a file, something useful, maybe a bunch of sales receipts or something, or a list of scores, I don't know, what other sort of things would we track in just a file? Most of the world nowadays uses databases for storing information, but again, files are still useful, and small local files can still be helpful for just storing little pieces of information here. And again, we don't really know how to work with the database yet, so that's okay. We can get to that later in other classes. How about we write some random numbers? Right, we always like random numbers here. So that was just another example. So let's make another file here. And we'll make this one, call this our lotto file output. And this will be, how about lotto numbers.txt. So we'll generate 6 random numbers, right? If we want to pretend we're playing Powerball and lose a bunch of money, we could do that. So and check if it's open. Is nice to make sure we're doing that. So if it's not open, try again. Otherwise, we're good to go here. And we can start. We could. I mean, we're just in main here right now. So if we were writing functions or writing classes to do things, using an exception would make sense. At this point, if we raise an exception, throw an exception, it's in our main method anyway. Like it's not going anywhere. Yeah, that would be good if we were using this somewhere else though, and someone else was going to use our code for exceptions. All right, so we want to generate some random numbers. So we need 5 random numbers, 1 to 69, if we're going to play Powerball, right? So let's get int number 1, math dot Kaplan math dot random. No, I have to import math, include math. Just rand. Oh my goodness, friends, it's Monday. Rand times 69 plus 1 should give me. This is not between 0 and 1, is it? All right, big number, modulo 69, give me 0 to 68, plus 1, gives me 1 to 69. Awesome. Now we'll do it 5 times. Number 2, 3, number 4, number 5. And then the 6th number here is 1 to 26. For I don't know why. I don't know who came up with it, but sure, why not? This will generate some random numbers. Now, you're not actually allowed to have repeats, though, in Powerball, right? Because they all come out of the same bucket here. So this doesn't quite work, right? So we need a little bit of a better solution here. Got a couple options, right? We could check if number 1 doesn't equal number 2 in sort of a loop, and then the loop number 3 doesn't equal 2 and doesn't equal number 1, and number 4 doesn't equal number 3 and doesn't equal number 2 and doesn't equal number 1. And that's a little bit tedious. Yeah, it's a little tedious. So I think if we used a vector of numbers, we could see if that number is already contained in the vector. It might be a little easier, right? So if we have a vector of integers here for numbers, gotta include vector, don't we? Include. Oh man, I am feeling old today. So the first one's fine. We can just push back, right? So take our numbers, push back a random number, right? And then we want to do 4 more, right? So for int number 4, oh, 0, numbers less than 4, number plus plus, 4 more times. We'll generate a random number. I don't know, random number. And then if that's not in the vector, we'll add it. If it is, we'll just keep on going, right? We can do that. Actually, this is probably easier than as a, how about a while loop then? We'll say while numbers dot size does not equal 5. How about that? And then we can now check if numbers, oh no, it's in our STL, isn't it? Or our, is it algorithms? Algorithms. To see if it contains. We did this before and I'm not remembering. Contains. Didn't we do this before? We did this before. Let's just go search contains. No? We didn't check if a number's in. We did this. I'm sorry. Contains a certain value. Yeah. Oh, find. That's what it was. Find. Find. Okay. Find. There we go. Yeah. Not even. It's not even in there. Find. Where's my find? Bless you. Didn't we do find in our algorithm? We didn't. Did we really not do find? That was it? Okay. Sure. from the beginning, from the end, it doesn't equal end. Numbers.beginning, numbers.end. What do we want to find? We want to find the random number. And find the random number does not equal, and if it's not there, it's going to give us the end position, right? Is what we get. So really, if it does equal the ending position, is what we want here. So if we look for this random number from the beginning to the end of the vector, and we get back the ending position, means it's not found. Right? If it's not found, then we can take our numbers and we can push back the random number. Right? And this just keeps on going. We'll generate a new random number until we get to size 5. I think that works. That sound reasonable? We can try it after. Then we can add one last one here, right? Another random number for our red ball. That was 1 to 26. So this one comes out of a different bucket. So the red number can repeat one of the white numbers here. Yep. All right. Then when we're done, we want to write our numbers to the lot of numbers file. For number in numbers, take our file output, and we'll add the number. And do we want to do one number per line? It's probably easiest, right? Add an end line. And then when we're done, we want to close our output. So now we can generate some random lotto numbers. Now, let's see what we get here. Lotto numbers. Lotto numbers. All right. That's a little small here. Sorry. Can I zoom? There we go. 42, 45, 56, 5, 57, and 21. These are obviously some winning numbers here. No, they're
42 is how much we beat Ohio State last year.
those are numbers. Yeah. So next time we run our program, we're going to get different numbers, right? So you do want to be careful, because when you go open a file, what happens to that file? Are we adding numbers to this? No, the file gets erased. Oh, they're the same one. We didn't seed our random number generator, right? Was that a srand and time? Now we should get new random. I want new random numbers. There we go. You guys know all the good tricks. All right, let's try it again. Open up our file. Hey, those look different. All right, 3 numbers in the 60s and 26. Wow, like some near the end values. All right, so do be careful when you open files, right? Because you lose what's in it before, which can be pretty bad, right? But for our purposes, this is okay. Every time we run it, we get new lotto numbers. Now, I wouldn't recommend actually using this for a real lottery, right? Because it's not a real random number generator. It's pseudo-random. And if anyone knows what our code is doing, you know, it's probably hard to predict the exact time that we run our program, but it is breakable at that point. So just be careful. Did I tell you the story about the people who would watch a slot machine with a phone camera? Oh, it was super cool. I think it was in Wired. There's a whole write-up here. So the programmers for a particular slot machine, would use the same random number generator to flash the images on the screen as it used to generate the actual winning numbers. So like it would like simulate a bunch of pictures going by. It was like a digital one, right? So it just has pictures of images going by like it was spinning, but it would use that same random sequence. So someone learned that if they took a video of it running, they could analyze what the random seed was and then send a signal back to the person playing in their phone to tell them when to hit the stop button. And they actually made a lot of money off of these slot machines because they're able to do this. What's that? Slot machine. Recording hack. No, what is it here? This one, I think. This might not be it. Yeah, oh man, I said a slot machine number reader exploit. Maybe that was one of these ones here. Yeah, yep. Yeah, it was a while you're right up. Here was, yep. So this whole write-up here. I am subscribed to Wired. I am. Why didn't you log me in? Log me in. I don't want to create a free account. I want to log in. All right, that's fine. We don't need to. Okay, now the pop-up went away. Anyway, it was really neat here. It turns out casinos do a whole lot of analytics themselves, and they realized that certain machines were losing money. And like, hey, this isn't supposed to happen. We programmed these things to make us money. Literally, like that's how they're programmed, which is ridiculous. People still play, but okay. Um, yeah, that's fine. That's fine. We can make that go away, right? That's just a modal. Can I make that go away? I think I can. Paywall. What? This one? Yeah, I mean, it was this one here. I just need to hide it, right? Oh, quite. Make it not show, right? I was trying to just delete element. Oh, it's the whole div. Delete that element. There we go. Oh, it cut it off. It actually changed the whole. Okay, they figured out people can do this sort of thing. That's okay. That's all right. Wired is actually a decent subscription. It's like $10 for the year. It's not bad. They run some good stuff. I don't make any money if you subscribe, I promise. I just find it interesting. So pseudo-random numbers are bad for actual things that need random numbers. Use some cryptographically secure stuff is the whole story. That's like the number one rule of cryptography is don't do your own cryptography. Seriously, just don't, because there's whole teams of people with PhDs who study this sort of thing, and they've gone on and researched these things. What? Smart people invent it and then they try and break it. Like the was it the first example of a quantum secure encryption was broken already by researchers. Like, no, it's not actually quantum secure. So they predict our current encryption schemes will be broken by quantum computing at some point in the future. So for what it's worth, nothing's actually secure on the internet. It's secure for now. And do people really are going to spend the time to break our communications years later down the road when they can easily on quantum computers? I doubt ours is the target. But, maybe. So just assume it's not secure, and you're probably a lot safer. We're going down some weird holes today. I'm sorry. It's a Monday. It's a Monday. Anyway, so we closed our file. Now we want to read a file. Let's go read a file. So come back here and steal our opening code. That makes life easier. We're doing file input. So now we're going to open the file for reading instead. So yeah, that was just fstreams. Okay. So we want to ifstream and we want to open. I hate their names here. They use terrible names. Input file here. And we will go and open the file. We can cut out all their garbage too. This was lotto.txt. And if it's not open, sure. Oh, look at it. We can just return. That's right. If you return anything other than a 0, it means something bad happened in main, essentially. Did we talk about that at one point? It's been a long semester, friends. been a long semester. Usually you return 0. That means it's a good thing. This is really old computing. It's been around for a long time. It used to be when you'd get computer software, it would come with a book. Back when they sold software on physical media and you didn't download everything. And in the book, there'd be a whole table of return codes. And just depending on which value you got, you'd go look up in the book and see what this return code meant. So you could use an integer to return a whole series of different, numbers here, and we just go look up what the message was. That's the fun story. It's not very fun, I'm sorry. All right, anyway, so if it is open, then we can go and read this out. So let's make our vector of integers. This is our, how about the winning numbers? And now we want to read until we get to really the end here, or if we haven't found a fail is pretty handy here. If our read is successful here, then we don't get a fail message. So we can check to see if it's failed. So we need an int for number. We can read in the number, and then if it didn't fail, we can keep on going. So you essentially just keep on reading until it fails with this process. Similar to checking whether or not we've gotten to the end of file or not. So this should work out pretty well for us. So we'll take our winning numbers, and we're going to push back the number, and then we'll read the next one. If it didn't fail, we'll add it to the vector. If we got to the end, right, our loop stopped, but we aren't at the end of file, this EOF end of file, then something bad happened. We failed, probably because we tried to input something to the wrong type. Right? Because in our case, we know it's just 6 numbers. It'll work out pretty well. But if we wanted to say, like, let's put a shopping cart together, we'll have the item name and then a quantity and then a price. We have to read out 3 different things, right, and kind of put all that together. We'll work on that one next as a fun example. We'll see if we can get this going. And then how about we just output what the winning numbers are here? So we can say for number, this is our number in, this is the winning numbers, and see out the number. Right. So we should be able to generate some numbers, output them here. Oh, I forgot to close the file. Sorry, we'll come back. Oh, could not open file. Is it? Oh, it was lotto numbers, right? It wasn't just lotto. Yeah, lotto numbers.txt. Look at that, it worked. Our error message worked. How handy was that? We'll output the numbers and see what we get. I forgot to close it again. That's right. Okay, so we generated 57, 55, 30, 51, 49, 22, and that should match what's in the file here. Look at that, it matches. So we wrote the file, we read the file. We could have just, used that same vector, but you don't always have a program writing and reading the file at the same time. That's kind of silly. We're just kind of trying to demo them both at once here. And then we should close the file when we're done. Take our input file and close it. Okay, so reading this is not too bad, but they're all numbers, nothing super interesting. So let's do another example. Let me move all this to something else. First examples. All right, so if we wanted to make a shopping cart, like or a wish list maybe. So as we're getting closer to the holidays, maybe we want to make a wish list and share that with people and say, hey, if you want to buy me a present, I would really like you to buy something off this list instead of picking something that I probably don't want. Because it's nice they thought about us and okay, I think you might like this thing, but some people in my life are terrible at that. I really just wish they would stick to the list. But it's okay. It's the thought that counts. I don't actually need any of these presents, so it's okay. If I get coffee that I don't want to drink because it has cherry flavor in it, that's okay. It was very thoughtful. I've never once asked my mother-in-law for flavored coffee. Been married for 15 years now, and I was dating for a couple more. I've known her for 20 years. Never once have I asked her for flavored coffee, ever. And every year, I get flavored coffee for Christmas. Flavored. Like cherry or vanilla or a bourbon barrel coffee. No. Well, I like black coffee. That's what I like. I don't put cream in it. I don't put sugar in it. I don't add flavors. I like black coffee. That's what I drink. But it's very thoughtful. She picked one up on a trip somewhere, and she was very excited to give it to me. So we made a batch, and it like ruined my coffee pot because it just stank for days. Like even my regular pots of coffee after that just had this lingering flavoring. I was like, oh, but it's okay. It is all right. A wish list. So let's make the file then for wish list. So what we probably want to do, because when we open a file to write it, it erases what's in it. So how about we open the file first and read what's in it, save that. Then we'll go ask for items they want to add to their wish list, add them to the wish list, and then when we're done, we'll rewrite the file. So we don't lose anything. Does that sound reasonable? And because I love classes here, it's a good way to kind of organize our data here. We can write a item class. Class for item. We'll have a private section, we'll have a public section. I just want to cheat here. Is that okay? Because I don't want to write a bunch of methods, and I don't really care at this point. So we're just going to have an int for quantity. We're going to have a double for price, and we'll have a string for name. Is that okay? And just make these public attributes. You're all going to be sad at me, aren't you? It's okay. Space standard. So we don't need anything private at all. We'll just have some public attributes. Now I'm going to do two things though. The two things I'm going to add to make my life easier is to give me a way to represent this item as a string so I can write it to a file. Right? And I want to add a constructor that takes a string that I might read from a file and turns it back into an item. Because otherwise I have to do this one piece by one piece by one piece. And there's nothing wrong with that. It would totally work, but I think it'll make my life a little easier and faster. I have a method like for string get, I don't know, line for file. We can do that. So we can return a string that has all of these values here. Right? So we're going to return name plus a space plus, or I don't know, we want quantity of the name at a price. I don't know. We can, any format we want really doesn't matter as long as we're consistent. So how about we do name, quantity, and price? So we want is it toString of the quantity plus a space plus a toString of the price. And we'll just concatenate all that together. Just smush it all together as one big ugly string. Okay. Then we also want to make our constructor then that will accept a string of this format and turn it back into one of these. Right, so we want to make an item that takes a string for line from file. Right, well, we're going to take that string and we need to convert it into this. So that was our IO stream. That we could do the input strings here. You said you did this before, so we didn't talk about it, but I'll just go copy it here. That's easy. Input string stream, right? Our input string, input string, oh, goodness, their variable names are the worst. S stream, include S stream, string stream. So we need an input string stream, input string, sure. Right, and we're going to give it then our line from the file. When we make this input string here. So we give it a string. This is now my input string stream, and then we can CIN off of this stream instead of the standard input stream. Right? Sorry if I think we had talked about you talked about this in 150. No one's disagreeing, so okay. You just have to shout at me. Really, that's all it takes. We're going to take our name. No, our input string. We have to turn into name first. So we have name first, and then we have quantity. Input string to quantity, and then we have our input string to price. Right. So we'll go and set all of our values here, given that string. Now, if this is the only way to make an item, though, it's going to be a little bit tricky for us to ask the user for new values unless they give it in this format as well. I guess that's okay. Or we could also then add another constructor, right, that takes a string for name, a int for quantity, and a double for price, right? Just things that make life easier when we're using our classes here. And this price, equals here, quantity. Okay, so two different ways. You can give me the string, or you can give me the individual values, and then we'll just return them all. They're all public, so you can just go set them and get them too. All right, but now we need to read our file first. So let's go make our wish list file, right? So we'll go open our wish list file and go read it here. I can't return a 1, can I? We'll just return. That's fine. So this will be our wish list.txt. We'll go open it up, and then let's try and read it here. As long as we haven't failed, right? We'll go and do this, and then we'll close it when we're done. So we need a vector. We got to go include our class here. So we'll include our item file. So we're going to make a vector of type item. Add this to, right? So this is our vector of type item. Is our wish list, right? And then we'll have a string, a line. We can read in the line. If it didn't fail, we'll take our wish list and we're going to push back an item given the line, right? And then we'll go read the next line. Read the line, read the line, read the line, read the line, yada, yada, yada. All right. If something bad happens, sure, if something bad happens, then we'll close our file. So now we should have the latest and greatest wish list vector of items from that file. Now this isn't going to work unless we actually have that file existing, right? So let me go open this real quick, because we can't open a file that doesn't exist. It'll be upset with us. Let's open our wish list.txt, and ours is empty. So when we try and read, it'll just fail right away, but it should be okay. Right? We just didn't read anything out of it. No worries here. Excuse me. All right, and then we'll go. Should we print out the wish list? Tell them what's in it right now. We could, right? So maybe we'll take that and we'll just see out it too. You can see up a line. I don't think we need the end lines, right? Because I think they're already going to come as we read the lines. Because it should grab that character. We'll see if it does or not. Okay, so I don't know, current wish list, maybe. We'll tell them this is our current wish list. End line. All right, then we'll go ask them if they want to add more things. Okay. Do you want to add more things to your wish list? Jump to your wish list. And then we'll get a string for their input here, and then we can see in their input. Again, probably tell them like, hey, should we give you a Y or a no or something? Yes or no. You know, or hey, enter the name of an item you want to add, or exit or done or something, because you don't ever want to buy a done or buy an exit. We got a couple choices here, but this is probably fine. And we can say while my input equals a Y. String. There we go. String Y. Oh my goodness. Y. I'm not having any luck today, friends. There we go. Well, it's a Y. Let's keep on going. So then we can get a string for the item name. Name. Enter the item name. See an item name. We can get the price and the quantity. So we'll have an int for quantity. You don't usually add the price. I don't know, maybe we didn't need price, but that's okay. Sometimes it's nice to like have the price listed for people who are looking at your wish list, right? That's probably a double. Here is the price. Then we make an item, right? Item, given name, quantity, and price. Item name, there we go. Item name. And then we'll take our wish list and we're going to push back the item. Then we'll ask them if they want to do more, right? Oh, this should go up top. Okay, repeat here. All right. How's that? Then when we're done, we want to go write the file. So to write the file, right, we need our output stream given the file name. File output, sure, given this is our wishlist.txt. This would be good to leave as like a constant somewhere, right? If I'm using it more than once, it'd be nice to have that defined, right? Just the good habits, right? Constant string, wishlist name. Is that better? It is better. It definitely is better, right? Okay. We can open it and then we'll loop through, right? So for item in the wish list, we're going to take our file output and we're going to write to it my item dot get line for file. Wish list. Thank you. Right, and then when we're done, we'll go close our file. File output close. So it should rewrite whatever was there plus the new stuff we added. It'd be nice to give them some functionality, like to remove an item from the list. But again, we don't have unlimited time today, so we can come back to that later. I'm sorry? Well, so we're pushing back on our vector. So we're reading in whatever's there first. Then we're just pushing back on the vector instead of like appending to a file. Yeah. Yeah, there's actually ways to open files for appending rather than overwriting it here, but we just haven't got there yet. So this is our other way of going about it. So we should be able to make a wish list. Let's see if it works. All right, current wish list is empty. Makes sense. There's nothing in it. You want to add more items to your list? Yes. What are we wishing for? Coffee. I wish for coffee. I want a dozen coffees, and they're like $1.99, right? Sure. You want to add more items to our list? Yes. What are you wishing for? Xbox. Series S, Series X? The original. An original Xbox. We have Xbox Ones in the game lab. Don't have originals. No, not in the game lab. How many of these Xboxes do you want? Just one. Item price. $50. Okay. Do you want to add more items to the list? Anyone else wishing for something? Vinyl? Is there a Y in there? Vinyl. Okay. How many of these do you want? Just one. And how much are these? Is that like an old record? Is that what that is? The vinyl records? My parents had one of those when I was a kid. And they're nerds. I'm sure you're not surprised. So the only record I remember ever playing was the soundtrack to Star Wars. Yeah. It's a pain to set up. And like you had to get the needle just in the right spot, otherwise like you skipped tracks and stuff. Like this technology was just no good. Yeah, ours didn't do that. This was old. No, you didn't have to crank it. At least it had the auto spin. Were there two different speeds for records, or do they all have the same spin speed?
There's 33 1/3, which is the regular one. And there's 25, which is for the single, but the original like 75.
I feel like it had multiple speeds, but I don't know this for sure. Oh, we did not.
I have one that has 3 settings. No.
We forgot to add our end lines here, so I'm going to put them in myself. And then we'll come back and fix our code. There's an end line. Okay, but it should now read it here and tell us what's in our wish list currently. Yeah, okay, so we got to add in the end lines as well. So when we read it here, thought it would come with an end line, but it did not. Okay, one more time. So stop and run. There it goes. So coffee, Xbox, vinyl. Fantastic. We're getting our data back out here. Should we add more things to our wish list? What else do we wish for? We want to make sure that it writes now and puts all this stuff back. A TV. How many of these TVs would you like?
This one.
4?
Yeah, four.
4
One
TVs.
was,
All right. I think I saw Walmart had a 50-inch 4K TV for $150.
yeah.
4 TVs. We can do that. Let's see. Huh. That doesn't look right. So it was right when we displayed it, but it's not right when we're writing it now, right? That is interesting. So this was the quantity, and this was the price. So we're getting garbage integers and garbage doubles here. How did that happen? That's really interesting. The file was good before, right? So when we read it, it did a bad thing, right? Track item using the line. Okay, this is interesting. Let's try it again. So let's fix our file here. Let's see what went wrong. Oops, wanted that one, that direction. Come on. But it did add our next item, right? It added the TV, and the TV was correct, right? So the TV wrote properly. It's only this one that failed, the vinyl that failed. Those were like $20. Oh no, vinyl 120. Okay, there it was. Yep. So it's oh, it's an L. Yeah. Okay, I thought that was a 1. Man, I really need my glasses, but I can't right now. All right, we'll put the file back. It should read, and we'll put a breakpoint in and see what's in our list here then, right? So as we're reading this here, let's see what we get. So our wish list then has 3 items. It has coffee with garbage price and garbage quantity. Is it failing to read the line? All right, what are we reading here? So we're reading the line. So the line is Xbox. I'm using the single CN operator, not the get line. Right? We stored this on an entire line at a time. This makes sense now. This makes sense. So we need to get line from our input file to the line. Did it get capital L line? CN dot get line? I'm confused. Let's just go cheat here. Get line. Yeah, it's just get line. Did I not include the right thing? I'm like including a bunch of these. I didn't include string. So get line was with string. That's where it comes from. Get line. Oh, it doesn't match the right type here. Get line, CN, and line string. Want my input file. Yeah, we can't do line here either. Was it? So it was like missing a capital? That's probably what it was. Oh my goodness. It's Monday. It's Monday. Okay, so if we get the entire line, then we can parse the line, not individual items. Maybe that'll work. All right, so let's see. So now our line then is coffee 12 $1.99. Looking good so far. And then get the next line. Our line is Xbox One for 50. Not an Xbox One, but a single Xbox. Better make sure we get that right. Vinyl. Get the line. We failed. Reach the end. Okay, close. So our list now should be prettier. There we go. These look good. Coffee, Xbox, vinyl, right quantities, right prices. So I feel like we'll be in good shape for this to work. We don't want to add any more items. We're done. And our file hopefully is still in a good format. Yes, still in a good format. We're happy. This is why we test our stuff. Bad stuff happens all the time. All the time. So in using the class, I don't know if this feels like less work to you. I feel like it's less work. Right? We can just get a single line rather than getting all the properties out when we write it and reading in all the individual properties and setting them, or like having 3 different vectors, or it's a nice way to group things. Right? And that's the whole idea with our object-oriented programming. If you've got nothing else from this class, hopefully you got that. That object-oriented programming generally makes our life easier, just for designing solutions. And that's the whole goal. Right? The computer could care less. It really doesn't care. But as we design solutions and think about ways of solving problems, having nouns and verbs and these ways of interacting with our classes is helpful for us. So, all right, how are we feeling about files, input and output? So if I wanted to, I'm not going to ask you to, but if I wanted to, we could say you should be able to save your blackjack game. We could do that, right? For the final project?
Oh, yeah.
Right? Like when we're playing the game in step 1, like we should be able to save the game at any point instead of just quitting, right? So we should be able to write the list of cards out currently in the shoe somewhere. Maybe that's its own file. Sure, it could be the shoe.txt with a bunch of files, a bunch of cards in it. Go for it. And maybe we had another file with the amount of money we had or something. I don't think we're actually tracking money. They said just $1 per hand or something. You can track how much you won, but we could say, hey, I had $100, and now when I paused my game, I was down to $50, or I was up to 125. We can have that information somewhere. It doesn't all have to be in a single file, but it could be. The problem with using a single file is sometimes it's hard to separate your data. Like, how do we know where the shoe is done and where the next thing starts? So a lot of times what we have to do is say, okay, the first piece of information here is going to tell me how many cards I'm going to read. So I'll read in an integer. Okay, there's 125 cards I'm going to read. Then I'll go for 125 times, go read out a card, add them to my deck for what's currently in the shoe. That's an option. That's a way to store that data. And then we could add in this, and if we wanted to have multiple player support and add in other fun features, that sort of thing, we'd have to track all that in our file, but it'd be doable, right? Be doable? Okay, cool. So we'll practice doing some file input and output in lab, and a little bit of ethics in the lab as well. Shouldn't be too bad. Pretty quick. The ethics is fun. We'll talk more about that on Wednesday, which is very useful. You don't want to end up in a bad place, for sure, or in a bad organization that does things. So we'll have some fun talks. I get to dunk on Uber a lot, and it's just a terrible place to work. So it's serious. It's awful. It's crazy. I don't know why people would want to go there, but sure. I'm sorry. Probably. I mean, they're a West Coast company. And there's lots of companies that pay well that aren't trash organizations. So, so there's that. All right, I'll go ahead and commit this. Anything else? We good? How's the final project going? Or you wait until after break? That's an option. It's okay. There's still some time. Okay. Yeah, we can chat after for sure. Sounds good. All right, you folks take care. I will see you Wednesday.